and we continue to search for ways to transform the sun's light into energy.
Light, or more precisely, light particles, are pure energy. They have no mass at all. We'd like to be able to use that energy to produce electricity. There are two possible ways of doing that. Directly with solar cells. That's relatively easy, but it's not terribly efficient. The other option is using what are called solar generators, or solar power plants. What you do there is heat water. The steam it generates is then sent to turbines, which then generate electricity. That's more complex, but also much more efficient.
Almeria province in southeastern Spain is home to Europe's biggest test center for concentrating solar power. On the 100-hectare site, researchers are exploiting the full force of the Andalusian sun to test and optimize high-temperature solar technologies. More than 20,000 differently shaped mirrors can be combined into specific formations to generate extremely high temperatures. In this way, the solar radiation can be concentrated up to 1,000-fold. The solar research facility was developed in partnership with the German Aerospace Center. The technology developed here is now being used around the world. More than 90% of solar power plants worldwide now use this technology.
Another unusual characteristic of light is that it's a wave. Those waves can be modified, or at least various properties of those waves can be modified, like the amplitude or phase. That's called modulation, and we can use that to transmit information. Take this example. Here we have a laser, which generates a beam of light. Now the simplest way to modulate it is switching it on and off. Each time I switch it on and off is equivalent to 1 bit. I can do that very fast, more than 1 billion times a second. That's what beaming technology is based on.
Beam me up. The crew of the Starship Enterprise made teleportation look simple. In real life, it's a good bit more complicated. Light can be perceived as tiny particles called photons. Two particles can be linked in an interdependent quantum state, no matter how far apart they are. This phenomenon, also called quantum entanglement, can also be used for teleportation. Physicists have already used it to transmit information from La Palma to Tenerife. An even more spectacular experiment was carried out by Chinese scientists. For the first time ever, they succeeded in teleporting from the ground to space. Working out of a base station in Tibet, they teleported a photon to a satellite in near-Earth orbit, 1,400 kilometers away. But the researchers could only recover 1 out of every 6 million photons that were transmitted.